gears will not be changing based on the type of the intermediate gears we are going to use. It will not be changed. We can see them later. So in a case of a simple gear train, in its simplest form, it will be consisting of one gear on each shaft. There will be an input shaft on the input gear. This will be called as a driver gear, and that will be called as a driven gear. And if you call this as a driven gear, and this will be driven gear, doesn't have any. Please don't try to think more about which is the driver and which is the driven. If it is not driven, and you can assume this is the driver, then that will be driven. If you assume that as a driver, this will be driven. That's all. And in between them, these two will be intermediate gears or idler gears. Now in this, what happens? On each shaft, there will be one gear. On each shaft, there will be one gear. How these gears will be fixed? These gears will be fixed by means of a key. A key is one which will be firmly engaging the gear to the shaft, so that whenever the shaft rotates, the gear also will rotate. This is what correct. Now, if the key is not there, simply the gear will be rotating without taking the shaft. Understood? Okay. Now, what is the compound gear train? A compound gear train is one. Here it will be consisting of more than two gears. It will be a gear train. Now let me look into whether it is a compound gear train or a simple gear train. Among the or between the driver and the driven, any one of the shaft or more than one shaft, they are having the two gears that we call as compound gear train. Now here you can see this. This is input gear, and in the input gear shaft will be having two gears. Definitely it is a compound gear. And you can see there the next one which will be having the three gears. It will be a compound gear. So we understood the meaning of a simple gear train and the compound gear. And whenever you are going to write the examination, please look into this and write like this. Okay, there will be a shaft and there will be one gear in between them. Please don't talk. And we say this is a simple gear train. This is a simple gear train. And how you can show this? I can show the top of this like. A simple sketch. Simple guess annotated. Now, if I say this is a driver and this is driven or follower gear, and this is called intermediate gear. Okay, now let me say this is gear 1 and this is gear 2 and this is gear 3. Now I am talking about the simple gear trains. Okay, and by definition, what is the meaning of velocity ratio? The velocity ratio will be a positive velocity ratio for the gear trains. For a particular gear train, the velocity ratio will remain constant. Correct? It remains constant because of due to a slack and friction will not be changing the velocity of the two gears. Now, what is the meaning of velocity ratio? The velocity ratio is represented by I. That will be equal to the velocity of the output gear to the velocity of the input. Or in other words, the velocity of the driven gear to the velocity of the driver gear. This ratio is called as the velocity ratio of the gear train system. And that remains constant for a particular gear system. Now here, in this, N2 by N1 is the velocity ratio of this gears. Velocity ratio of this gears. Now, please look here. In this, N2 by N1 is equal to T1 by T2. N2 by N1 is equal to T2 by T1 by T2. That is equal to T1 by T2. This is one. And now for this particular assembly, this is the driver and this is the driven. And for this particular assembly, this will become a driver and this will become driven. Correct or not? Now let me see this. N3 by N2 is equal to T2 by T3. That is equal to T2 by T3. I have taken these two equations. By looking into the in what is meshing of gear 1 and 2, this will be a driver and this will be driven. And the output velocity to the input velocity will be the velocity ratio, that is N2 by N1 is equal to T1 by T2. T1 and T2 are the number of teeth of the driver and the driver. That is equal to D1 by D2, that is the diameter of the driver to the diameter of the driver. Now forget this, come to these two assemblies. These two, in these assemblies, this will be a source, that is the velocity of the output gear to the velocity of the input gear. N3 by N2 is equal to T2 by T3, that is equal to T2 by T3. And here N1, N2, N3 are the velocity, the speed of the gears 1, 2, 3 in RPM. And T1 and T2, T3 are diameters of the gears 1, 2 and 3 respectively. And T1, T2, T3 are the number of teeth on the gears 1, 2 and 3 respectively. Okay. By looking into the figure, I have written this. Now, the total velocity ratio of this gear train will be equal to N3 by N2 into N2 by N1, that is equal to T1 by T2 into T2 by T3, that is equal to T1 by T2 into T2 by T3. You can see this N3 by N1 is equal to T1 by T3, that is equal to T1 by T3. That means to show if you are having many intermediate gears in between them, the velocity ratio will not be changing. You can see that. Correct? No? You have so many gears in between the driver and the driven, the intermediate gears will not be changing the velocity ratio of a particular gear systems. Okay? This is the velocity ratio of this particular setup, a simple gear train system. What is a simple gear train system? With a suitable example, explain the velocity ratio of a particular simple gear train system. And now here, let gear 1, 2 and 3 are the gears facing each other. Let T1, T2, T3 the diameter of the gear T1, 2 and 3 respectively. And T1, T2, T3 are the number of teeth on the gears 1, 2, 3 respectively. And the diameter already I told D1, D2, D3 like that. Okay. And if we want to write gears A, B, C, then NA, NB, NC, TA, TB, TC, DA, TB, DC. You can write. Or simply you can write 1, 2, 3 respectively. Okay. This is how we can find the velocity ratio of a gear train system. Now let me look into other one, a compound gear train system. I'll try to show you how this is. Let me take the same figure and explain it. It will become very easy for us. Now here, look here, whether it is a compound gear train or a simple gear train. Definitely compound gear train because the gear B and gear C are fixed on the same shaft, so that it will be a compound gear train system. Now, one should have a small idea about how the rotation also will happen. In the examination, there will give us a gear. There are 3 gears, 1, 2, 3 respectively. Number of teeth of the gear, 1 will be 30, and on this will be 40, on this will be 50. The speed of this gear driver is 1200 RPM. Find out the speed of the driven gear and its direction. Then ask us. Now please look here. If it is rotating in the clockwise direction, this will be rotating in the counterclockwise direction. If it is rotating in the counterclockwise direction, this will be rotating in the clockwise direction. You can see that. Right now, this will be rotating in the clockwise and this will be rotating in the counterclockwise. You should have this idea. Enough. Now this will be represented by clockwise, this will be counterclockwise, and this will be clockwise. Just have a small idea about this. Now please look here. I have shown the arrow mark. It is rotating in the, there A is rotating in the clockwise direction. And one of you please tell me the gear A is machine with which gear? The gear which is machine with the gear A. Gear B is machine with the gear, and gear C is machine with the gear A. Gear C is machine with the gear A. And how to find out the velocity ratio? Just I'll be giving you a small example. Here, now let me look into the velocity ratio of the gears A and B. They are engaging each other. Now, NB by NA is equal to the output velocity to the input velocity will be equal to TA by TB. That is equal to dA by dB. Anyone can able to understand? These are the two gears I have taken. Gear A is machine with the gear B. So output gain is B here. So definitely NB by NA is equal to TA by TB. That's equal to TA by dB. You say it is equation 1. Now the gear C is engaging with the gear D. Please look into the figure. The gear D is engaging with the gear C. Why I am showing you many times? Because they will be giving us the problem. We should have to slightly analyze it and try to do the problem. The gear C is engaging with the gear D. Then output gear is D and input gear is C. Then ND by ND by NC is equal to. Now here you need not worry. In the reverse direction, it is TC by TD, that is equal to TC by TD. This is the second equation. Now another one. Okay, now let me find out what is the velocity ratio of this compound gear train system multiplying this NB by NA into ND by NC, that is equal to TA by TB into TC by TD, that is equal to TA by TB into TC by TD. This is the velocity of this system. Now here one can see this. The gear D, B and gear C are on the same shaft. Even though these gears are having the different diameters, what happens? The speed of these gears should be same because they have been mounted on the same shaft. So that means the speed of the gear B and speed of the gear C be equal. That means from the figure, the speed of the gear C is equal to speed of the gear B. The speed of the gear B and speed of the gear C will be equal. So that ND by NA is equal to this. ND is what? Output gear, and NA is the input gear. This is how we can able to calculate the velocity ratio of a particular gear system. Now here, instead of giving you TC, TD, TA and all this, they will be giving us the numerical values. We can able to think of. You can understand? Very simple way you can able to remember this. Okay. Now, this is I had given an example of the rack and pinion, how it will be useful. Okay. I don't want to show that once again. Here the simple gear train, the velocity ratio of the simple gear